Most automakers in the US market offer the J1772 port for the level 1 and 2 AC charging, and then the two CCS1 pins in their charging port for DC fast charging. Makers like Ford have even built vehicle to load systems on the two CCS1 pins. Tesla owns a vertically integrated system where it builds its own charging equipment, cables, DC fast chargers called superchargers, and most importantly, the four car models Tesla Model 3, Y, S, and X. It has its own connector, which is a sleek option that carries both the AC and the DC pins. The vertical integration allows Tesla to offer a seamless experience to its customers. Tesla's products have offered a distinctly better experience to its customers, and the CCS1 has been the opposite. With common failures, customers have been distressed on the entire electric vehicle adoption move. This has been mainly on account of the sheer diversity of cars that the CCS standard needs to support. Then the bulky connector with an externally locking pin has been a major cause of failure. Unlike Tesla's, which is sleekly built to lock to the charging port from the inside. First Ford on May 25th and then GM on June 8th this year announced adoption of Tesla's NACS to enable their customers access to Tesla's supercharger network. On June 20th, Rivian followed them. This is a very complicated situation in my opinion. CCS1 is at the forefront of US Navy funding, and as mentioned above, the two systems are poles apart on delivering for the users. I like to examine the situation to the best of my understanding. I'll welcome comments and corrections where relevant. To get the basic picture, let's focus on the three typical entities involved and their relevant issues, and examine how these developments impact all three of them. The first are the non Tesla automakers. US automakers, mainly Ford, GM, and Tesla, now appear in a solid camp on the NACS. The other big global names with products selling worldwide have a distinct problem. For that matter, even Ford and GM. Rivian is an exception, and their anticipated adoption of the NACS was least surprising considering its recent arrival in the market. Large automakers with global products have much to worry about beyond simply a charge port in a single market. When an EV is launched for the world, they need the CCS2 port in Europe, the Chauji port in Japan, the CCS1 in Latin America and South Korea, besides the existing customers in the US, the GBT in China, and probably the Chauji which is expected there soon. So, what are automakers looking at when considering the NACS adoption? The NACS pins do both AC and DC in a single connector. They now need extra switching gear in the actual charge controller of their cars. That's additional cost, particularly for DC fast charging. That's a small fraction of the overall charging of customers. CCS2 works so seamlessly in Europe that probably some of the large automakers there don't even visualize the problems here in the US. Yet, those that do, particularly Ford, GM, Rivian, and probably Mercedes soon, see the futility of a 300 to 500 miles range EV that would struggle to charge in the first 100 miles of that long trip. That's a catch 22. It gets more tricky for cars with the 800 volt system, which can't charge to their potential even with Tesla's NACS. Tesla's version 3 superchargers currently support 500 volt but can be easily scaled up. They already use 880 volt to 1000 volt DC buses to connect the dispensers. Tesla can bump it up to 1000 volt with a minor reconfiguration and, most importantly, different cables. Things that one expects Tesla to do in no time. Tesla's version 4 is a next gen system which I know little about, but will surely have higher charge limits. Besides the same, automakers may have other concerns adopting the NACS. Tesla could own the data, and that could be a competitive threat in the future. Tesla on its own has done so well staying alone, so won't be surprised if that could affect Tesla. Though as of now, we don't see any of those concerns, and Tesla effectively has so far proved up to it when delivering. At the onset, the equipment manufacturers should not have a problem supplying the NACS connector. There is currently no NACS cable. This I believe Tesla will create and provide. In the short term, I don't see any problem as adapters will be available of all kinds and types. Tesla itself will create one for CCS1 for its deal with Ford, GM, Rivian and those to follow, and technically that should solve the interface issue with NACS. However, it's worth noting that adapters are not long-term solutions. Most develop resistance over time, and at this high amperage is dangerous. The challenges lie thereafter. When the dispenser creates a connection and a handshake to establish communication, an adapter can't by itself identify the car, dispense current, and charge the customer. The Tesla app allows non Tesla users to create a Tesla account and use the chargers, like the ones on the Tesla Magic Dock. Those have now probably got stalled after the Ford and GM move. The main factor here is for a charging session to happen seamlessly, which should work on Tesla dispensers. Third party suppliers will need to make the port available and address the issues as stated. Technically, charge point operators should be able to simply add the NACS port, much like we see the Chademo port on that corner stall. The big thing is interoperability. To illustrate the problem, consider the truly strange situation existing with old Teslas themselves. Most old Teslas, I guess, were built using MAC addresses for charging communication. NACS will use the ISO 15118-2 standard to communicate. And as funny as it may seem, older Teslas themselves may not work on NACS. That is until their hardware retrofitted. That's going to be a shock in waiting for those cars when they roll in into a newly set up NACS stall. Tesla is probably retrofitting older Model S and X vehicles and will do the same for the others. But this situation illustrates the complexity of the problem on the whole. All such failures will be laid at the doorstep of the operators. That, I think, captures at least some part of the entire situation with DC fast charging here in North America. It's a rapidly evolving subject, and I'm sure those of you with interest are keenly following the developments. I have presented this subject the way I understood it. I'll keep updating it here as and how I see the changes. And let me know in the comments what you think. Until the next one, take care.